Hello, here we will be installing DHCP Failover feature for Windows Server 2016. So far, if you haven't been following along, we have created a domain with two DCs, and a DHCP role is installed on one of them, and we have one test PC. And here we will be doing it all remotely, I believe. We'll install the role from a different computer, and we'll plan and configure the DHCP failover feature, and we'll do that all remotely. And after this, we'll start poking around with file servers. So here we can see I've got 3 VMs running, Windows 7 in the background, my second DC, and as we can see here, it only has Active Directory, Directory Services, DNS, and the default file and storage services. And on this DC, we do have Active Directory, DHCP, and DNS installed. DHCP is working right now already. It's handed out a lease, and actually it's a reservation. So we have a reservation set up, and that's working. We have just the basic scope options as well. So we want to create a failover scenario where if this DC1 goes offline or breaks, or the host of that machine breaks and DC1 goes offline, the service and role will be switched over to use this machine. And it's actually not just failover, it actually does load balancing as well, so it's a nice feature. And really today, if you have 2 DCs or 2 spare machines, there's no reason why you shouldn't do this, because each of your servers will need to be updated and rebooted occasionally. Okay, so first what we need to do is on this DC we need to install DHCP. So you can do that remotely, either from your PC or from if you have the RSAT tools. But first, if you want to do it remotely, you need to add other servers to manage and type in the name. Select that and move it over to the right. And that'll just take a second to load in here. Now what we can do is add a role and feature. Next, and instead of on this DC1, we want to pick DC2. And we're going to install the DHCP Server role and the management tools for that on that second DC. We don't need any other features right now. And next, install. I'll come back when that's done. Alright, I did want to show you. Here we can tell that it's working remotely when this graph starts to do something interesting here. So, I won't waste your guys' time with this though. Just watching a graph. Okay, so that's all done, and now again we can complete the DHCP configuration. This says that it's going to create the following security groups, but we've already done this because we already have a DC. And now authorization. Well, I'm going to skip this just to show what it's like, and then click on commit. Security groups done. Please restart the DHCP server service on the target computer for the security groups to be effective. Okay, well, I'm not going to do that because I'm not using those security groups, and hopefully it doesn't mess us up. Okay, so now, again on DC1, I want to be able to manage that other DHCP role remotely. So we can add a server, DC2-cat. Click on OK. I can click on Browse as well, but I believe this should work. Yep. And if the, okay, good. So here we can see that the red arrows are red arrows and not green check marks. So that means that something isn't working. If you right click on it, nothing. Oh, wait, now it's there. Okay, so here we can see that it's not authorized to be a DHCP server, whereas DC1 is. So, and then if we expand this, we can see that nothing's configured here as well. So let's just leave that and see what happens when we try to configure failover. So right click on IPv4 on your working machine. It enables high availability. It also provides load balancing. This wizard guides you, of course. Partner server. Nothing in that list. Let's try and add it manually. DC2-can. Found that. Okay, click on next. Okay, this is the interesting part. So by default it gives it a name here, and you can see that DC1, it's kind of hard to read, but here's one server, then it's got a dash, and the second server. So the relationship, these two are going to be failover partners. Maximum client lead time, 1 hour. Mode, load balance, or a hot standby. So hot standby is your second DHCP server is ready to be used, but it's not actually doing anything. It's just kind of there, and it's not responding to requests or listening. It's just there. If you pick load balance, then they're both active. They're both listening. They're both responding, sharing the workload. And if you knew that one server was super slow, maybe it was old and the other one is faster, you could, edit the priority there. Shared secret. So here I have a top secret password. That might be password. So that information is going to get shared between the two machines so they can communicate securely. Click on next. It'll be set up between these two partners for this one scope, and it's load balancing. Click on finish. Successful. Okay. So now if we were to look at the root here, look at this. Let's get rid of that window. Here we can see the failover relationship, and it's active. So now what happens if we go down here? Did it authorize it? It didn't. So if we were to turn off DC1 right now, things would break because we didn't quite do this properly. Unless if I refresh, yeah. So what we have to do is authorize, and now it can do what it's supposed to do. Oops, what happened? Refresh. It's got the scope in there. Authorize. I did before it can be assigned. Refresh. Why aren't you authorizing finance? It is bound to an IP. Authorize. Let me restart the service and see, maybe that was a step I should have done in that previous screen. That looks better. Okay, so my bad. And it's authorized as well. Okay, so now if we click on here, we can see it's got all of the configuration. It's got the static IP and the scope options and the reservation, so it's copied and replicated everything for us. So now, if, for example, let's say DC01 just magically went offline. Disable that. Config. Release. That's too slow. Disable, re-enable that. Oh, it's trying to get an IP address right now. Let's see. Actually, yeah, I'll stay on this machine here because we want to see. It's got an IP address now. So now let's check the DHCP log just to confirm. Of course, oops, of course it had to get an IP here because the other one's off. System 32 DHCP there, and what day is it? Friday. I should have known that. There we go. Packet drop, client ID, hash mismatch. Interesting. But I'm not too sure what these ones are all about yet, but we can see that the IP address did get on from this host here. So we know that the failover works. If we turn the NIC back on again, let's see what happens. We'll wait till this gets set up. So ping lab PC 123 so it can communicate. Let's just see what happens now with. I'm going to delete this lease from this computer and I'll disable and re-enable it. I'm being impatient. And it'll show up here again because we know, but we don't know which machine provided us the IP. I wonder if this would tell us. Config all. Here, DHCP Server is .3. Okay. So let's see what happens if we disable and re-enable it. See if it changes to .2. .3 answered again. Come on. Probably need a bigger test environment to be able to really test out this load balancing, but we'll see if we can get it to work here. Okay, so I figured out why it's not doing what I was hoping, in that it seems that this DHCP server 10.3 is always responding, and that is to be expected because if you Google this here, it basically says that the DHCP server will convert the MAC address into a hash, and then if it falls between, if you're using a 50-50, if the hash is between 1 and 128, then the first DHCP server will respond, and if it's between 129 and 256, then the other server responds. So it's not really true load balancing in that it'll one request will respond to the first, and then the next will be on the other server. It's more of half of your clients will be load balanced to one machine and half to the other, and if failover does happen, the remaining DHCP server can still take up that entire load. So that's my lab, and we'll end it here. Next we will start talking about file servers.